Hey everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to be in lesson 11.8. We are on page 437. This lesson is about complex fractions. Now you might not remember what complex fractions are. The word sounds, oh man, that must be really hard if they're complex. That's not what complex means here. Complex just means that basically you have two fractions in the same fraction. Let's review. What is a fraction? Well, a fraction is just a division problem, right? As we've gone through algebra, we have found that basically every time we see a fraction, we divide. So what we have here is we have two division problems in one. That's all. Not as complicated as you think. It is called complex, but don't let that scare you. Let's look at the screen. It says two methods for solving complex fractions. We can do what's called order of operation, and we've been doing order of operation all year long. It's a little bit more complicated here in complex fractions, but it's not too bad. And then we can do multiply by the LCD. That's my preferred method that I like, but I'm going to show you both because maybe you will like the first one, and you can use either one that you like. You're going to get the right answer if you do it right. That's the key. You have to do it right. If you do it wrong, you're going to get the wrong answer. If you do it right, you'll get the right answer. All right, let's look in our books on page 436. Page 436. What we're going to be doing here is we're going to do the first one, the order of operations. Actually, I'm going to do the same problem with both methods. That way you can see and maybe kind of determine which one you like better. All right, so in the order of operation, the first thing that we want to do, this is on page 436, we want to combine fractions to form division of two single fractions. All right, what does that mean? Here's what we want to do. We want to do this fraction up here, and then we're going to do this fraction down here. In other words, we want to take x plus x over 3, and we want to combine them together into one fraction. Well, how do we do that? We find the LCD. Okay, you do have to find the LCD on this because you have to add them together. Well, the LCD is pretty easy in this one. It's 3. So what we're going to end up with is multiplying this by 3 in order to get our fraction to be denominator 3. And so we're going to get 3x plus x. Okay? So we had to multiply that by 3 so that we could get that to be a denominator of 3. So 3x plus x over 3. We can add that together now. And so the numerator here is going to be 4x over 3. Okay, that's what that becomes right there. The second thing that we had to do is now we have to do this one. Okay, and we're going to have another, this is going to be our denominator to this fraction. So how do we do this one? 2 over x plus 5 over 1. Our LCD here is x, so we need to multiply this one by x in order to get x here. So we're going to get 2 plus 5x over x. Can't really do much with that one, right? There's nothing we can do there. We can't simplify it, so let's just rewrite it. 2 plus 5x over x. Okay? All right, so now we have converted it basically from... Look, we had a division here, we had a division here, and we had a division here. So there was 3 different things going on. We still really have 3 different divisions going on. We have one there, one here, and one here, but we've simplified it all. So now what we can do is we can just go ahead and divide this. Okay, how do we divide that? Well, we divide it by saying 4x over 3 divided by 2 plus 5x over x. How do we divide in algebra? That's right. We multiply and we change this and we flip the second one. So 4x over 3 times x over 2 plus 5x. There we go. And now what we want to do is we just want to go ahead and multiply what we can multiply, cancel what we can cancel. Well, I don't see anything that I can cancel because this has a plus sign in it, so I can't just cancel the x's. So there's not really much I can do. So I'm just going to multiply here, and that's going to give me 4x squared. I'm going to multiply here, so that's going to just distribute through there. And I'm going to get 6 plus 15x. Now, I might be able to see if I can reduce it. I might be able to see if I can factor something out. But that's our answer right there. All right, there is one little other part of this that we do have to get. So if I go back up here to my original problem, that was this right here. I have to recognize that in my denominator, I do have one denominator here that has an x. So x cannot equal 0, because if that equals 0, then the whole thing becomes undefined. Okay, so I would go back to my original and say, okay, I do have an x cannot equal 0, so I do need to put that x cannot equal 0. So those would be my two answers, 4x squared over 6 plus 15x, and x cannot equal 0. All right, so that is using the, basically we just followed order of operations. All right, so let's go ahead and solve this one. This is the exact same problem that we just did. It's from the same problem up here. We solved that one by order of operation. We're going to solve this one. It's very similar, but we're going to solve this one by finding the LCD. The LCD of what? Well, the LCD of this and the LCD of this. In other words, the LCD of the numerator and the denominator, we're going to combine the LCD. So what is the LCD? Or in other words, how can we get rid of the denominator? What can we do here? Well, if this one is over 1 and this one is over 1, what's the LCD? So we have 1 times 3 times x. So there's a 1, there's a common 1, so we take that 1 time. There's a 3, so we take that, and there's an x. So there's the LCD, okay? So it's 1 times 3 times x, or 3x. That's our LCD. Now what we want to do is take our LCD and multiply it or distribute it through everything. So 3x times this. Distribute it. 3x times this. Now let's watch what happens here. Get rid of this. All right, let's see what happens when we distribute it. So we get 3x times x, and we get 3x squared. When we take 3x times this, let me just move this over here so you can see it. 3x like this. This cancels to 1, and this cancels. So what do we get? We get x times x, so we get x squared up top. We'll do the same thing here. This cancels the x, and we get 6. And then if we multiply this by 3x, we get 15x over here. All right, now we just want to combine our like terms up there on top. What do we get? We get 3x squared plus x squared is 4x squared. All right, down here, we can't really do anything. I mean, theoretically, I guess we could pull out a common 3. So we could put that as 3 comma 2 plus 5x. That would be fine. And you notice we got the same thing. We could have pulled out the 3 here too if you want to. I'm not going to make you do that. You don't have to pull out the 3 there, but you can if you want to fully factor that. Probably a better answer if you fully factor it. And one thing to notice here as well, we have an x in the final answer, so that x cannot equal 0 again. So anytime that you get that in the denominator, you can't have that. So there we go. Two different ways to do the same thing. But either way, you have to find the LCD. Either way, you have to multiply it through. So it's really whichever way that you like better. I wrote down here, finding the LCD is a more efficient way and is typically easier when working with rational expressions. Let's do one more, and let me kind of explain to you why it's maybe a little easier to work with the LCD than it is to do it the other way with the order of operation. So let's do LCD here, okay? So if you look, this would be over 1. So what's our LCD? Well, we just take what we have. Look, we have common x, so let me write LCD over here. So we have 1 times, and you don't have to write 1 because it's identity. Okay, and we have x plus 1, and then we have a pair of x minus 1s, so that would go there as well, x minus 1. We just had to write the pair once. So that's our LCD. Now, what we have to do with that LCD is we have to multiply it everywhere. So we're going to multiply it here, x plus 1, x minus 1, times this one, and times this one, x plus 1, x minus 1, over 1. We have to do it here, x plus 1, x minus 1, over 1. And we have to do it here. And I'll just leave it right here. We'll just use that one, over 1. Okay? So we have to do it 4 times. Why? Because there's 4 terms. Look, there's 4 terms right here. So we have to do it 4 times. We have to multiply it by everything that's there. Now, what do we get? Watch what happens here. We get a cancel, a cancel. Let me just go through and cancel everything. Then we'll write everything that's left over. Okay? And then here, nothing cancels. And then here, the x minus 1 cancels. So what's left over? All right, so up top, we have this. What is that? What's x minus 1 times 1? It's just x minus 1, okay, because the bottom canceled. Then we have minus, what's left up here? X plus 1, minus x plus 1. Put that in parentheses, that's important. And then we have our fraction bar. And then we have what is down here on the bottom. What's down here on the bottom? Well, that's left over because nothing canceled there. So x plus 1, x minus 1, plus, and then what's left over here is the x plus 1. All right, now, that's a lot of stuff going on right there. We're not quite done yet. We still have to combine like terms here on the top and see if there's anything that we can cancel. All right, let's go ahead and rewrite this once we distribute our negative sign here. So it's got to go to both. So we're going to have x minus 1 distribute minus x distribute minus 1 over just the denominator. Just rewrite the denominator, x plus 1, x minus 1. And then we can actually take this plus and distribute it. Not that you really distribute, but we can just kind of go through there and write plus x plus 1. We don't have to leave that in the parenthesis. Okay? Now what we want to do is we just want to combine our like terms. So we have an x and a minus x. Those cancel. We have a negative 1 and a negative 1. So we get negative 2 on top. What do we get on the bottom? I don't know. Let's just go through and combine our like terms. All right, so when we multiply this, what happens? Well, we're going to kind of have to come over here to the side and multiply that. It is a distributing problem, but notice that this is a conjugate. So what is this going to give us? It's going to give us an x squared. When we FOIL these two terms, we're going to get negative 1x and positive 1x. Those middle terms are going to cancel, and we're going to multiply that, and it's going to give us minus 1. Okay, so that is a difference of 2 squares is what it comes out to. So you want to take that and write that down here. X squared minus 1. That's basically solving that. And then we still have this plus x plus 1 plus x plus 1. We can now simplify this out. Minus 1 minus 1. Or plus 1, so that goes away. So your answer is going to be negative 2 x squared. Those cancel, plus x. Okay, and that would be your answer. But we have to do something. Because we canceled some things out of the bottom, we're going to have to set some things equal to 0. What are some things that we canceled out of the bottom? Well, let's go back to the original problem, wherever that was. There we go. Well, we had x plus 1 and x minus 1 and x plus 1 as denominators. So we have to cancel those out. So x plus 1 equals 0. So switch it over to the other side. X cannot equal negative 1. And then we also had x minus 1 equals 0. Switch it over to the other side, and we find out that x also cannot equal positive 1. So those are the two excluded values. So there's your answer. Negative 2 x squared plus x. If you want to, you can take out this x. So you make it negative 2 over x times x plus 1. and that would be fine there if you want to take out that. If you don't want to take it out, you don't have to. I'm not going to require you to factor that out. So there's your solution. All right, fun, right? Yeah, you guys love these. All right, it's complicated, and it just takes. It's not really that bad though. It just takes a lot of steps. It takes a lot of continuing to go over those steps that we've been talking about over these last few lessons. All right, that's all I got for you in this lesson. I hope you understood everything. If you didn't, slide it back and watch it again. See you later. Bye-bye.